Welcome everyone. We will start with our next chapter, inverse trigonometric function. To introduce this chapter, I'll start with one example. Tan 30 is equal to root 3. We have known this since class 9. If I take the tan onto the other side, that means onto the numerical part, the remaining part that is there is my angle. So that means tan inverse 1 by root 3 is equal to tan 30. This part that we are getting, the tan inverse part, the inverse of any trigonometrical angle with the numerical value gives you the angular value. This is all about the inverse trigonometric function. Now, inverse trigonometric function, we will be dealing with two types of values. That is, firstly is the principal value, which is the smallest value that you can obtain for the given numerical value, and the general values will be the periodical angles that you'll be obtaining by repeating it with n pi or 2n pi plus minus 1. We have here, find the principal value of cos inverse root 3 by 2. So I assume my cos inverse root 3 by 2 to be y. If I take this cos inverse y onto this side, it becomes cos y, that is equal to root 3 by 2. So cos y is cos pi by 6. The cos gets cancelled from both sides, so y is equal to pi by 6. A few important properties are written here. You can refer to them here, or else you can also refer to it from your books. One of the most important properties is sin inverse 1 by x is equal to cosec inverse x. This we are obtaining from the concept that sin x is equal to 1 by cosec x. Another very important identity is sin inverse x plus cos inverse x is equal to pi by 2. This is obtained from the trigonometric identity sin theta plus cos theta is equal to pi by 2. Similarly for the other two relations. Coming over to the formulas, we have here sin inverse x plus sin inverse y is equal to sin inverse x root over 1 minus y square plus y into root over 1 minus x square. This is the formula for, if you apply it in just the general form of trigonometric functions, this is also the formula for sin A plus B. Similarly, we have the other formulas given here, which we will be using later for solving the sums. Now we come to another important property of the inverse trigonometric function, that is the interrelations among the three angles. We solve a few examples to make the concept more clearer. We have here, write the function in the simplest form. Tan inverse root over 1 plus x square minus 1 whole divided by x. We assume tan inverse x equal to theta, so tan theta is equal to x. We are substituting this x is equal to tan theta in this part, so 1 plus tan square theta. This portion, it becomes sec square theta using our trigonometrical identities. With the square root, it becomes sec theta minus 1 by tan theta. We are changing this to 1 by cos and this to sin by cos. We are left with this after taking the LCM. This, with the multiple angle formula, we get this as 2 sin square theta by 2, 2 sin theta by 2, cos theta by 2. Cancellation gives me tan theta by 2. Tan inverse and tan, it gets cancelled. The by 2 comes in front as a half, and the theta is tan inverse x. Moving on, we have simplify tan inverse cos x minus sin x by cos x plus sin x. We divide the numerator and the denominator by cos x. We get 1 minus tan x by 1 plus tan x. This one can be written as tan pi by 4, so that we can reduce it to the formula with tan pi by 4 minus tan x 1 plus tan pi by 4 into tan x. This is the value for tan pi by 4 minus x using the concept tan a minus b form. Tan inverse and tan it gets cancelled out. We are left with pi by 4 minus x. Next we have, find the value of tan inverse 1 plus cos inverse minus half plus sin inverse minus half. We know tan inverse 1 is pi by 4, cos inverse minus half is 2 pi by 3, and sin inverse of minus half is minus pi by 6. Algebraical solving with this gives me 3 pi by 4. Next we have prove tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse half. We start working with the LHS. That becomes tan inverse A plus tan inverse B form. We get this. Algebraic solving gives me tan inverse half, which is my RHS. Next we have find the value of tan inverse 2 cos 2 sin inverse half. We start with the innermost angle sin inverse half. This sin inverse half is pi by 6 as we know. 2 and 6 gets cancelled, pi by 3. Then it becomes cos pi by 3. Cos pi by 3 is half. 2 and 2 gets cancelled, so tan inverse 1, and that leads to pi by 4. Another example is sin inverse 1 by 5 plus cos inverse x is equal to 1. In that case, we have to find x. So sin inverse 1 by 5 plus cos inverse x is equal to sin inverse 1. We are taking this sign onto this side. This sin inverse 1, we know it is pi by 2 using the principal value. Cos inverse x coming onto this side, this is using the identity, I am getting it as sin inverse x. Sin inverse, it cancels out from both sides, so x is equal to 1 by 5. Now we will solve a few of board sums. A question from 2017. Prove that half cos inverse 1 minus x by 1 plus cos x is equal to tan inverse x. We assume x is equal to tan square theta. The clue that we have got is from the question itself. So x is equal to theta is equal to tan inverse root x. We are substituting this x as tan square theta. This is the multiple angle formula, cos 2 theta, cos inverse and cos 2 theta, it cancels out. 2 here and a half cancels out. We are left with theta, that is tan inverse root x, which was my required proof. Next we have another question from 2017. It says sin inverse x plus sin inverse 1 minus x is equal to cos inverse x. In that case, if x is not equal to 0, find x. Using the concept of sin inverse A plus sin inverse B form, we get this expansion. Cos inverse x, we change it to sin inverse root over 1 minus x square. The sin inverse gets cancelled out from both sides, and then we have the simplification. Simplification leads to either x equal to 0 or this inside bracket is equal to 0. X equal to 0 is not admissible because it is given in my question that x will not be equal to 0. So the remaining part of the bracket is equal to 0. Taking the square and on both sides, we get x is equal to half. Another question from 2018. 3 tan inverse x plus cot inverse x is equal to pi. This cot inverse x, we are writing it as pi by 2 minus tan inverse x. So 3 tan inverse minus tan inverse gives me 2 tan inverse x, and pi minus pi by 2 gives me pi by 2. This 2 comes onto this side, it becomes pi by 4. Tan inverse x is equal to pi by 4. So x is equal to tan pi by 4, hence x is equal to 1. Another question of 2018, it's given that tan inverse A plus tan inverse B plus tan inverse C is equal to pi. In that case, we have to prove that A plus B plus C is equal to ABC. What we are going to do is, we take tan inverse C onto the other side. It becomes pi minus tan inverse C. That is equal to my tan inverse minus tan inverse C. Here we have tan inverse A plus tan inverse B formula being applied. And then the tan inverse, it gets cancelled out from both sides. We are left with A plus B whole divided by 1 minus AB is equal to minus C. Bringing everything onto one side, simplifying, we get the required proof. One question from 2019, it says that solve sin 2 tan inverse x is equal to 1. We take the sign onto the other side. So 2 tan inverse x is equal to sin inverse 1. Sin inverse 1, as we know, is pi by 2. This 2 comes down here. Tan inverse x is equal to pi by 4. So x is equal to tan pi by 4. Hence x is equal to 1. Another question from 2019 we have tan inverse this plus tan inverse this is equal to pi by 4. We take this as A and this as B. Applying the formula, we get tan inverse A plus B whole divided by 1 minus A into B is equal to pi by 4. So this is the simplification, and that is equal to tan pi by 4, which is equal to 1. Further simplification gives me 2x square is equal to 1. So x is equal to plus minus 1 by root 2. Next question from 2019. Sec inverse x is equal to cosec inverse y. In that case, we have to show 1 by x square plus 1 by y square is equal to 1. We have sec inverse x is equal to cosec inverse y. We change it to cos inverse 1 by x is equal to sin inverse 1 by y using the properties of inverse trigonometric functions. This sin inverse 1 by y, we are changing it to cos inverse root over 1 minus 1 by y square, so that we can cancel out the cos inverse from both sides. So I am left with 1 by x equal to root over 1 minus 1 by y square. If I square up, I get x square is equal to 1 minus y square. This 1 by y square moving on to this side gives me my required proof. Hope the concept was clear. Any further queries or doubts are most welcome in the comment line or else on my WhatsApp. Thank you.